Hey, 20-2s. Welcome to another video all about quadratics. Because you're loving quadratics so much, I thought I'd make you another video. This one's about what's known as the factored form of a quadratic. And so the factored form is going to help us find some big pieces to our graph. So let's try this out here. So the first thing I want you to do, grab that graphing calculator, is I want you to look at this factored form here. F at x is equal to x minus 6, x plus 4. And what does this do to help us find the x-intercepts? So I want you to hit pause on your video. I want you to graph that, find those x-intercepts, and then come on back and we'll talk about it together. See you in a moment. Okay, friends, so you should have graphed that, and you should have seen something that looks something like that. My graph's pretty ugly because I got the caffeine shapes going on here, but more or less something like that. So what did this tell us? Well, what I want you to notice is that the x-intercepts of this thing, I'm just going to write that function down again right here, that the x-intercepts are at 6, 0 and negative 4, 0. So I want you to notice something really, really important here. Hey, negative 6, 6, positive 4, negative 4. Okay, really when we're in factored form, the factors are giving us the x-intercepts, but the signs are different. Okay, the reason why the signs are different, this will always be the case, is we're going to talk about it more in the next unit of quadratics, but when we go to solve, so if I said x minus 6 is equal to 0, when I go to solve, I get x is equal to 6. So what does factored form tell us? Factored form gives us the x-intercepts. That's the most important part of this whole thing, is that factored form gives us the x-intercepts. Now, how do we use that to find the other key characteristics of our graph? Well, friends, if I know the x-intercepts, we're at negative 6, 0 and positive 4, 0, then guess what's halfway in between those? The axis of symmetry. So remember, to find the axis of symmetry, we take the average of these 2 points. And that'll be negative 1. So now I've got the axis of symmetry. Okay, so factored form gave me the x-intercepts. Now I've got the axis of symmetry. Now watch what we can find. Let's find the minimum of this graph. This graph has a minimum because it's opening up. Well, how do I find the minimum? Because if I go back and look at my graph here, like I can't see it. It's way down there somewhere. Here's how I'm going to find the minimum. The minimum means I need the y value. But guess what? The minimum's part of the vertex, and it's when x is equal to negative 1. So what I do is I say f at negative 1. And I go and plug that back into my function. I let x equal negative 1, if you want to think of it that way. That's exactly what we're doing. So f at negative 1 is 5 times negative 5. F at negative 1 is negative 25. There's my minimum value. Just like that. Okay, so again, what would we do? We found our axis of symmetry first, and then we sub that into our function to find our minimum. What else do we know? I'm going to switch to hot pink because hot pink is awesome. We now know our vertex. It's at negative 1, negative 25. And guess what? If we know our vertex, now we can say our range. Our domain's the reals. That's the easy question. But our range, y greater than or equal to negative 25. And then we write that properly. Y such that y is an element of the reals, like that. And then the last thing, friends, well, we've got pretty much everything. The only thing I think we're really missing is the y-intercept. Well, to find a y-intercept, that's when x is 0. So all I'm going to do again is I'm going to go back to my function, and I'm going to let x be 0. And I'm going to get that. And then f at 0 is, that's going to end up being negative 24. So our y-intercept is at 0, comma, negative 24. So friends, holy cow, by having something in factored form, we can figure out everything about the graph. So this is just a tiny bit important for you in this unit. But wait, what if it's not in factored form? Okay, if it's not in factored form, yes, we could just graph it, but I'm asking you to do it algebraically. So we need to factor this thing. So to factor this guy, this trinomial, I say to myself, I need two numbers that multiply to negative 3. I need two numbers that add to negative 2. So what are my numbers? Well, the two numbers that multiply to negative 3 and add to negative 2 are negative 3 and 1. So because this is a simple trinomial, we're going to factor. That's x minus 3, x plus 1, just like that. Well, there it is. We're in factor form. So what do we now know? We now know we've got an x-intercept at negative 1. We've got an x-intercept at 3. I know looking at my constant term, so again, the constant term is that right there. That's my y-intercept. It's right there. It's opening up because the lead coefficient's positive, so I know this graph is going to do this. And it's going to come like that. Okay. Now, before I draw this, I'm going to find that minimum first, okay, or else my graph will be a little off. Okay, so how do I find that minimum? Well, first, I'm going to find that axis of symmetry. So my axis of symmetry is the average of my x-intercepts. So it's 3 plus minus 1 divided by 2. And that sounds like 1 to me. So my axis of symmetry is that imaginary line. It's going to go right down there like that. Okay, and so I've got that axis. And once I've got that axis, then my friends, what I'm going to do is find that minimum. So let's go find that minimum. So to find the min, I'm going to let x equal 1. So I stick that into my function. I say f at 1 is 1 minus 3, 1 plus 1. And I'm just going to go sideways here because I'm running out of room. That's very bad to do mathematically, but I'm going to do it. I apologize. That's going to be at negative 4. So my minimum is at 1, negative 4. Let's go back up to our graph. There's my minimum, just right there. And hey, now I've got everything I need. Draw that graph. Oh, it's beautiful. Look at that, except for that I missed the intercept there. Friends, everything, as soon as we factor it, we have everything. So y-intercept, always write as a coordinate pair. That's the constant term. She opens up because the lead coefficient's positive. The x-intercepts were at, what did we say they were at? Negative 1, positive 3. Just like that, again, coordinate pairs. The axis of symmetry was at x is equal to 1, and we had a minimum value of negative 4. There it is. So factoring, friends, is going to be important. Okay, so make sure you know how to factor definitely a simple trinomial. That's going to be really important. We will have to factor some complex trinomials as well, but those are covered in the lesson in the notes. Okay, friends, we're almost there. Last example. Last thing we have to do is we have to work backwards from the graph to determine the equation. So I notice the information I was given. I see two x-intercepts, and they did not give me the vertex. The vertex is there, but I don't know where it is. So when I'm given the equation and I know the x-intercepts, what I'm going to do is I'm going to use factored form. And factored form looks like this. Now, I'm introducing something here. You see that A right there? That's that lead coefficient. Now, in the last couple of examples, that lead coefficient was 1. See that right there? It was 1. And in the example before, it was 1. But it's not always 1. So that's why we put that a there. So what do I start with? Well, I know my x-intercepts are at -1 and +4. So that tells me my factors are the opposite, +1 and -4. But what about this a? Well, to find a, if I want a, I'm going to say a is, what is a? Well, I'm going to I need to know what x and y are. Well, do you notice we've got this other coordinate pair here, the y-intercept? So I'm going to let x equals 0, and I'm going to let y equal -2. I'm going to sub that in. When I sub that in, look at what happens. Now I've only got one unknown. So now what we have to do is just slowly solve for a. 1 times -4 is -4, so I'm going to call it -4a. Divide both sides by -4, and we get +1/2. Now, we've done all this beautiful work, and I'll see kids just go, boom, I'm done. Move on. No, you did all that beautiful work, and I'm not going to give you full marks because I'm a huge jerk. You have to, the question said, write the equation of the function. You have to write it. There it is. Okay, so when we've got the graph and we have to make the equation, if I'm given the x-intercepts, I'm going to start in factored form. And then I know the x-intercepts give me the factors, and find the a value by subbing in the point. All right, let's wrap this all up. Here's a nice little summary for you. So when a quadratic function is in this form, we call it factored. And the beautiful part here is it gives us the x-intercepts. So the function will have a maximum value if the graph is opening down. That's when a, the lead coefficient, is less than 0. The graph will have a minimum when it's opening up, when a is greater than 0. The x-intercepts come from the factors here. And remember, the sign always changes. So at R0 and S0, whatever those happen to be. The axis of symmetry is the average of these two x-intercepts. Then we find the coordinates of the vertex by subbing the axis of symmetry back up into the function. And the y-intercept can be found by letting x equals 0 and solving for y. There it is, friends. There's a lot of stuff going on in this video, but once you got the steps down, it's not bad. See you next time.